Welcome to 232, stopping the spread of malware. Here's our goals for today, but I'm going to skip right ahead into the main part because this first part talks about routing and it's an in-person class activity. I'm not doing that in this video. Watch this video though, yourselves, because it's pretty nice to introduce Wireshark and kind of stuff we're doing today. But I already did in class. I'm moving on. Launch the lab. Actually do that before watching the video, so you can have that up in time. A reminder, we have our login machine and we have our web server, and then there's the internet. Like, this is what we're actually connected to right here. All right, so we're going to start Wireshark. I think this lesson kind of steps through a lot of things, but sometimes it's hard to read the directions. Just follow along just by reading. So, if you get stuck, watch this video. Pause and skip forward or whatever. Going to click on Wireshark. Going to click the fin right here. Boom. And that'll pop up Wireshark in the lab. Now, you're going to be using this a lot in this class. Actually going to full screen it. Hopefully you can see it on the video. I don't know if the font is too small. But okay, this is the main screen. There's a lot of new stuff here. So maybe you get a software update, skip it. Now, Wireshark is a way to like observe the data going around the network. And there's a lot of stuff to configure, but we're not going to bother with that. Just follow the directions right here. So, hey, one of the things that we usually have to do is filter stuff, because if you look at all the traffic on a network, and especially in this lab, you're going to get the actual lab's network traffic, and you don't want the network traffic between like you and this virtual machine. You just want to have the other traffic, because that's virtual machine wouldn't really happen in real life. So select Ethernet 2 interface. So go to step 10. So, okay, it's selected. It's the only option. And then recall the data comes in over a specific port. Includes the data in your security lab, and Wireshark, the packets for the security lab will be mixed in with interesting packets, right? So we want to filter out the security lab packets. So what we're going to do in step 11 is where it says capture using this filter right here, we're going to type in the phrase not port 3389. So go not port 3389. And then I think we just hit enter. Yeah, so every time we use this, we're gonna be doing this like every time to filter out our traffic. So I'm gonna do that and just go hit enter. Sure. So this is gonna capture all of this is like all the traffic happening on this network. But it's filtered out that other stuff. Oh, did it actually do that right? See, I don't know. I don't know if I was supposed to hit enter, so I'm gonna try that again just in case. I think I was. Not port 3389. And then, but I want to follow the directions exactly what they say, just in case not. To start the capture, click capture and then start, or click the blue fin icon. We're going to hit blue fin. Oh yeah, probably don't hit enter right there. And if you did that, I think it just didn't apply that filter. That's good. Oh, maybe it did. Okay, this is all good right now. So it's just stuff that's happening on that network machine. All right. You may want to expand the Wireshark to full screen. Now in the applied display filter, type ICMP. All right. So up here, this is the other filter. Go ICMP. Not V6, just that. ICMP, and then we're going to hit enter. This will filter packets, so you only see ICMP packets. What is ICMP? Protocol to manage IP addresses. We'll learn about later. Don't worry about it. Just do that for now. Now, you'll notice there's no data in this, and this should be what happens because you haven't generated any ICMP traffic. So we're just filtering out the other nonsense, because if you don't use these filters, you get a lot of traffic. So the Wireshark, you can use the ping command to test a connection to another host by sending individual packets. So what ping does is you're just like pinging a different IP address, and then it'll just say, hey, are you there? And it just comes back and says, yes, I am. And it's a way to kind of see like your connection speed time to whatever IP and and even if it exists. So let's give Wireshark some traffic. From the taskbar, open up PowerShell. Enter the ping command. Which one was PowerShell? I think it's this one. Yeah, the blue one with it. There was like PowerShell, and then there was that other one, like the command. I forgot the name of it right now. So we're in here. We're going to type ping 172.30.0.13. We're going to go ping 172.30.0. Already forgot 13. And so when you hit enter, and then it's going to ping, and then you should see replies. Now notice as I did that, it was going back and forth. Now, what is that address 013? I bet that's my server here, right? So this is me right now. What I'm doing is I'm pinging that web server, and it's responding to me. And so what I'm seeing, and this Wireshark, someone in chat saying something. All right, thank you for letting me know. What this is doing is capturing all traffic on this like network, and that network just includes those two computers. So you're seeing this ping traffic right here. All right, maybe you kind of determine what's going on a little bit. Document the ping command, summarize what it does and what it returns. So what it did right there is it sent 4 pings, 32 bytes of data a ping. It gives you the time it took to come back, so less than 1 millisecond. And then, so it sent 4 and received 4. It didn't lose any packets. And then the round trip time was like nothing. And that's probably, that's got to be accurate. This is a server. You're supposed to be direct connected to these things, so it should be instantaneous. You tried pinging you could try pinging like different websites, like even on your home PC. Like if you ping it by like I don't think you need IPs. I think you just do it by the website. Google.com. It'll come back. I think so. Okay, so TTL equals 64. So TTL stands for time to live. Basically, it's how long before it gives up on that ping. Or how many router hops. So when you're trying to ping someone, it's got to hop through a bunch of routers. And if it can't find it in 64 hops, then it ends right there. I think, didn't we do something like that earlier? Or I'm getting confused with last year. Anyways, let's minimize PowerShell. Moving on. Wireshark should now show active packet data. All right. Shown in figure 6. So you should see something like this. Top packet panel is the packet list pane. In the middle is the packet details. And then you got the packet bytes. So here's the list of every packet that came in. And it kind of gives you a timestamp of when, source, destination, protocol. Okay, a bunch of stuff. This is the details in the packet. And these are the actual bytes of the packet. All right. So let's see. So as these kind of came in, if you remember after I did that ping, they just kind of came in one at a time. This is each packet coming in. When you click on a packet, notice this is like the details for the packet right here, right? And that kind of changes. And then these are like the details, but like in byte form, like 1s and 0s, but they're actually representing this in hexadecimal instead. The hexadecimal is like a 16. It's 0 through 9 plus A, B, C, D, E, and F. So it's base 16 instead of base 10. But this is this and this are the same thing. It's just ones in hexadecimal form. All right, or source, or what do they call it? Packet bytes. Sure. You're running Wireshark. Use the source, destination, info columns in the packet pane list to answer the following questions. What is the destination IP address for each ping request? So the destination for each ping request. Well, that's a ping request. The destination was, and these are all the destination 172.30.0.13. That makes sense because that's what we were trying to send it to. What's the destination address of each ping reply? Well, replies are going to be .6, and that's like us because it's responding to us, their source, right? So we send out 6 sends to 13, and then 13 sends to 6. That's the reply. Observe the middle pane of Wireshark, the packet details pane. It shows the packet structure and contains the fields of the packet. All right. Yeah, there's a lot of details in here. You're like, What's neat is you can hit these arrows. We'll have to be doing this later. Look at some details. Oh, like in step 17. In the packet details pane, click the expand arrow in the front of the frame 1, and the arrow changes down, and the frame details are displayed. So, oh, you get a bunch of detail. And you move this down. Oh, a bunch of details here. Ooh. Ooh. Oh, yeah, that could get overwhelming. If you saw that video where it had all that header information for the packets, watch that. I think a lot of that information's down here too. I think they put it in English right there. Among other things, the frame data contains the time the packet arrived. This is called the timestamp and the current system time for the host. Timestamps. Okay, so you can get the arrival time, all sorts of neat stuff. Important part of exchanging data over a network is the ability for any host to find another host. Since IP addresses can change and networks can be reconfigured, hosts may need a way to uniquely, reliably identify another host. Oh, a media access control MAC address. So you ever heard of MAC address? So, we have this IP address. It's kind of like your address on the internet. But that could change. Your computer goes to a different site, or sometimes every time you log on, your internet provider might give you a different IP address. So how do you be uniquely you? And we do this through MAC addresses. So network like your hardware components on your computer have MAC addresses, especially like your network card. The thing is, I think like everything has a MAC address, right? And it's kind of a way to say, hey, that's you on your computer. These are unique. Like all network devices all over the world have a unique MAC address, right? Every time someone builds a new network card for a new computer, they get assigned a new MAC address around the world. How do you make sure everyone's unique? Ooh, that's a good question for the next video, for next time in class. MAC addresses are often used in digital forensics to connect attack data. I might be wrong with this, but I think a lot of things are every piece of hardware on your computer, a lot of the big stuff has a MAC address. Actually, I got to learn more about MAC addresses later. All right, so MAC address, its network card has a unique one. How are they assigned? They got a system, just like how IP addresses are assigned or like website names are assigned. There's bodies that say, hey, your Linksys, here's your numbers. Like how credit card numbers are assigned, like Visa and MasterCard can have, how can they all use a 16-digit number but not overlap with each other? There's some controls on how things are assigned. So let's collapse the frame entry, and we're going to go to the next one right here. So Ethernet 2. So this gives us MAC address information. So your MAC address, this is hexadecimal stuff. We have our destination and source right here. I think those are MAC addresses, right? Yep. So, hey, not just your IP address from each of those. There's the MAC address for the destination and source right there. That's a way to uniquely identify people. MAC address are shown in parentheses the end of the destination source. They are similar in form to the data you're above. What is the MAC address of the destination host? The MAC address of the destination host is this thing, 282.0D EC94.2D. You type that in. Address of the source of the destination, and then the source is right there. Okay? Boom, boom. The bottom pane of the Wireshark is the packet bytes pane. It shows all the information in hex, also called the hex dump style. We use to confirm that important data, such as usernames and passwords, are encrypted. There in the course, you use that pane just to do that. So yeah, this is like the details written in English. You can read it. This is just what it looks like in the bytes and stuff. This is what it actually is being sent in hex, but it's really ones and zeros. All right, now this lesson talks about different types of attacks, like they were in the video. And the first one's the ping flood attack. So one way a hacker can attack it is just send a lot of ping requests. Like we did that one right there. That's great. What if they started receiving millions of ping requests at once? The computers have to take some time to respond to those. And yeah, they do them really fast. But if you have a lot of them happening at the same time, it slows down. It doesn't know which is real and which is fake, and it's hard to filter that out. So it just handles each of those. But like just like you go to a restaurant, a bunch of people show up at once. Like you're sitting there, you're like, oh, I want to go to McDonald's, or I want to go to John Smith Subs. But someone put a Grubhub order for 30 subs like 10 minutes before you arrived. Now you got to sit there and wait for a half hour while John figures out the rest of his orders. That happened before. You're sitting there going, really? Basically a ping flood attack, but with subs. If the ping request being unreasonably frequent, it's called a ping flood attack. Your attack can come from another host. In this case, the host running a Linux-based operating system. Confirm the Wireshark is running and actively capturing packets. Okay. So, yep, we're still going. So, we're still working. We didn't close it. Next, double-click the PuTTY application on the desktop. So, we still have this going on. Wireshark's still going. I didn't close it. Didn't ask me to close it, did I? No. They're saying this kind of stuff of like you're coming back the next day. Minimize the window. Wireshark will continue. Double-click the PuTTY application. So PuTTY is this one. Uh-oh. Oh, did you freeze on me? Oh. Does that sometimes? I'm going to hit refresh. We're going to double-click this one. You can log into the Linux machine that hosts the cybersecurity training site, the Bank of Virgil. Remember from last lesson. All right, we're back. So in the host name, enter the IP address of the Linux machine, 172.172.30.0. 172, oops. 30.0.13, right? Leave port 22 as the default option and then click open. Oh. All right, we get a login thing. Cool. Login as root with the password tour. We go root. Oh, that's like root backwards. Now, notice when I typed in passwords, it didn't display anything on here. I was typing, but especially like Linux and stuff to keep your password secure, they don't put like the actual letters you're typing up there, or they don't even put like stars to like hide when you're typing. It just looks like nothing's happening. So you are typing, it just doesn't show you doing anything to try to keep it more secure. Get used to that, especially with like Linux related stuff. Issue a ping to the Windows host where IP address is 72.0. Okay, so I want to go ping 172.30.0. What is it, 6? The ping command continues to ping. Okay, so let's do this. So it's kind of like I'm pinging my actual virtual machine, right? I'm actually logged in the other machine, 13, and pinging this, and it keeps going. Notice the time is taking longer and stuff. Okay. After 5 pings, type Control-C to interrupt. Oh, too bad. Too late. Control-C stops it. Okay. It just pings forever. Cool, I guess. In the Windows host, confirm the Wireshark detected the new network traffic. So let's pull up Wireshark again. Yeah. Like, remember there's like barely anything? And like, so this is the new stuff. Yeah. Okay, so it did. The source and destination IP address and the replies and requests are opposite from last time you observed. Yep. So where last time the source of the request was 6 and destination is 13. Now the source of the request is 13 with a destination of 6. It's flipped. So the neat thing with Wireshark, it's not just getting like traffic related to the number 6 computer, right? It's just getting any network traffic on there because it sees everything. So it doesn't have to be the source. Because now we are doing it from the other thing. Okay. The Linux-based operating system provides help file called manual pages, or man pages for short. So one other thing you can do if you're in Linux for this, and we're going to get to more of this in Unit 3, is we can do, if you don't know what ping does, it's kind of like looking at the readmes. So I can go man ping, and this gives me all the stuff on how to use ping. You look at this and go, what? There's little options you can do in ping, how it's supposed to be formatted. Yeah. Okay. We'll get into more of that later. To find out, use the manual ping. So to view this, you can hit spacebar to scroll down. You can search for something in there. Like sometimes the manual is really big. Oh, geez, there's a lot in there. Hit spacebar. Wait, okay. Okay, I want to figure out what the -I flag means. Okay, so I'm going to do man ping gun. You can hit up to do the last command. I'm looking for -I. And that's right here, interval. Wait interval seconds between sending each packet. The default is to wait for 1 second. You know how it kept like going? Okay, so you can make it wait before sending the next one. What is the ping I-2? So if I did this, my guess is this would mean 2 seconds. Yep, wait 2 seconds. Put it 2. Sure. Necessary, reissue the man ping command. Use the man page general single ping command with the options listed. Okay, so it says, hey, you're going to make a ping. Flood the host with many ping requests. And separate each ping request with a 0 time interval. So I can set, time interval to 0. Specify the packet has a packet size. So if I want to look these up on how to flood the host, -F will do a flood ping. All right, you don't have to put anything in this. For every echo request sent, a period is printed while the, okay, cool. And then there's the other thing, it wants to have a packet size. So how do I set the packet size? I don't see anything on the packet size. Packet size S specifies the number of bytes to data sent. Default's 56. So then I can make a packet of 4,000 bytes. You want spoilers? Here's this. So we put -F and -I. -F doesn't have any numbers associated. -I, you put a 0, and because 0 seconds. And -S, you put the 4,000. And then you put your IP address. Okay, so I'm going to try this. I'm going to hit Q. Am I supposed to? Oh, wait, no. I just want to ping. Go -F. I don't think it matters what order these are in. So I'm going to -I. Prove that. -F and -S 4,000 with 1, 2, 30, 0, 6. Oh, so it's sending pings every time there's a dot. I'm going to stop it. Oh, I sent, wow. I sent a lot of packets right away. Okay, so let's do that again and watch the traffic. So I'm going to hit up to get my same command. I'm going to watch the Wireshark traffic. The idea is that, where's my scroll bar for this? Go to the bottom. Yeah, it just keeps growing. You'll see a bunch of these. All right, so I'm going to stop it. On the Linux, I interrupted this with Control C. I was already ahead. You'll see the Linux command prompt again. In the Wireshark login, click the red stop icon. So we're actually going back to Wireshark. Gonna hit stop. So it stops collecting. I think I got plenty of data. Save a screenshot of your Wireshark window that includes both the ping request and that. Okay, so do that. So you have a bunch of these ping requests in here. Yeah, that's my problem. It didn't like that it didn't. Couldn't see the scroll bar on the side. Okay, now I can. Cool. Yeah. Moving on. Ping flood preventions. How do we prevent this problem? In Wireshark, you saw that a ping issues a record. So what if someone has that going on a lot, just keeps going? I mean, you can overwhelm a system potentially, especially if a lot of computers do it at once. Wireshark, you saw a ping issues an echo request and echo reply using internet control. Okay. Routers use this protocol to send information about network devices to protect the computer from a ping flood. You can deny one particular ICMP function responding to an echo request. So that to slow this down, you just say, okay, don't respond to these pings. And your login machine, launch Windows Firewall with advanced security. Okay, so we go Windows Firewall. How do I get to that again? I think we just type Windows Firewall with advanced security. So you start look in the search thing. Let's open this up. All right, I think we played with this before. Yep. I don't know if we did. In private profile, make sure the firewall is on. Select inbound in private profile. Where's private profile? Make sure the firewall is on. Check. Select inbound rules and sort the rules by protocol. Okay. Inbound rules, and let's sort by protocol. Okay, now we're sorted by protocol. One of the first ICMP v4 is going to be file and printer sharing echo request. Disable this rule. Okay, so we're going to disable this one. I'm going to click this and I am going to disable rule. Done. In Wireshark, start another capture section. You don't have to save the previous. Okay, so we're just going to start a new one. I don't want to start a new one or just going to capture again. Oh, wait. Continue without saving. There we go. From the Linux machine, issue another ping flood attack. Okay, so hopefully I have that thing open still, right? So I'm going to do ping flood again. Just hit up. Do it again. Observe the packets in Wireshark. So what's Wireshark look like? Okay, so it's a bunch of requests, but there's no responding. So it's getting requests, or there's traffic requesting to this, but it's not responding to it, so it's not going to get overwhelmed. Congratulations, we saved the computer. Let's interrupt that ping command. All right, and then we're done. Sweet. There we did it, folks. Ping flood. So hopefully we're going to be doing more of this, but that was day 1 of Wireshark. Thank you.